Welcome to a video in the USC CNC lab. We've got a slightly different project today. This is several components from our drone. On the inaugural flight of the drone, it was crashed, and because one of the propellers fell off, I think, and then in the crash, there was a problem with the batteries, and they ended up shorting out, catching on fire, and destroyed part of the drone. So it's been a lengthy process to try and repair it. The project today, we're not quite happy with these components. These are 3D printed, and they've got some serious flaws in them. See, that one's broken, and they're all the same. It would be nice to machine this, but what we're going to do is design it in a CAD program, and then we're going to 3D print it, and then maybe at a later date we'll come back and machine it. Another modification that's being made at the time, we're going to try and incorporate this board into it. So we're going to try and fit it in this area somewhere. There seems to be enough room. We might have to modify a few little things, some of the geometry, extend some of the poles. There's poles that radiate out that carry each propeller. So we may need to just offset them by a few millimeters. It's not going to make much difference to the performance. And this board, look, I don't even know what it does. It does something. So I'm working with Bernard on this project. He's asked me to give him a hand. And this will be a great little thing to print on our 3D printer. And when it's finished, I'll show some footage of that. But what we're going to do is get started in a new CAD program called Onshape. Now, I registered for Onshape beta program some time ago, but I never used it. So today's going to be my first day at trying out Onshape. It's creating a private document. As a free user in Onshape, you get 5 free private documents, which is not to say 5 free parts. It's kind of like it's hard to explain. I think it's more like a project, but that'll probably become clearer. I think the first thing I need to do is sketch. So we're going to select the top plane, and we'll click on that to look at it. And now I want a polygon tool. Now, how do I set the number of sides? So this has got 1, 2, 3, 4, 5, 6, 7, 8. But the polygon on the screen's only got 6 sides. Create a regular polygon defined on a circumscribing circle. Click for the center circle, drag to the desired size. Click again to set size and activate field. Okay. So you just create it, and then you edit the number of instances. This is different to how I'm used to working in SOLIDWORKS. In SOLIDWORKS, you have to specify how many sides you want before you do your first click. Otherwise, you're stuck. Right. And now I can just drag. Hey, that's pretty cool. I like that. So let's drag to 12. We'll do 3. Obviously, won't do 2 because this can't be a polygon. Let's try type in 12. So if I type in 12, it will actually do 12. Enter. Now, just roughly, I'm going to measure with my calipers the outside. So I think it needs to be about 100 millimeters. Okay, so I'm selecting this line. I'm going to put a horizontal relationship on this, just so it snaps. And now we'll do another inscribed polygon on the inside. It'd be nice if there was a right-click shortcut to bring up relations and snap them on now in the same way that SOLIDWORKS does it. And I'll just do a symmetric, which I guess would be similar to what we would say is mid-plane in SOLIDWORKS. And just measuring, so I'm just going to measure that, and that is about 25.5 millimeters. Back to isometric. All right. The next feature is this little cutout here. So you can see this tube that has broken off and it's still installed. It just sits on that little shoulder that's set the distance back, and then it's got two little screws on the end that I guess that would just compress the plastic enough to make it clamp on. And then over here there is another fastener that goes all the way through to give it a bit more positive clamp. So we'll put that little rebake in there. That circle's aligned with the origin. I don't need to put any other relationships on it. So when I measure the bore, that is about 20 millimeters. It's a little bit rough. The tube is about 20.2, and the bore, I measure this one, that one is about 20.1. That one's about 20. That one's about 20. So we'll just put it down as 20 millimeters for now. The 3D printing is going to be a little bit rough anyway. And how deep is it? It's 8 millimeters deep. I'm also struggling with navigation in this because I'm used to using a 3D mouse. Now I want to do a circular pattern. I think the first thing I need to do is put in an axis. So I'm just going to select the front plane and just do a sketch from the origin. Extrude to did not regenerate properly, select face. Okay, so I created my feature, but it just didn't do anything because there was a problem. Normally SOLIDWORKS that'd throw out some alarms and say, "What are you doing?" Well, I'm going to try and skin this a different way. So I've added some entities into the sketch, and I'm going to just select this region here. Right, so I've got that. Maybe that's been my problem there. Well, that worked. Let's see where we can fit this. Now that is 82 millimeters in diameter. So let's do a bore there that's 82 millimeters. It needs maybe 5 or 6 millimeters clearance on the bottom. My biggest worry using Onshape was that the lag on the internet was going to be unworkable. So I'm using this at uni at the moment, which we do have pretty good internet here compared to most people in Australia. I don't know how I would go at home doing this, because even though I've got a broadband connection, it does kind of suck. Okay, that works. Inside looks pretty awful though. I'm going to change this entity, so let's bring it in 2 millimeters, so we've got a reasonable shoulder. Now our last extrude failed because now our sketch selection has changed. That looks better. Much happier about that. Now the original part has these faces protruding all the way through, which I guess is so the cables can go all the way through as well. So I'm going to do another extrude all the way through. It looks like our sketch region selected. We've got remove. Let's change up to surface. Okay. Hey, now it works. I guess the thing I'm not used to is this reordering. In SOLIDWORKS, that Sketch 5 would be embedded in Extrude 4. So if I drag Extrude 4 up the feature tree, it would automatically bring Sketch 5 with it. It maintained the parent-child relationship. And for some reason, Onshape doesn't do that automatically. I don't know why. Maybe there's a setting or something where it will do it. Now I see where the problem is. I can kind of work around that. But to me, it's a bit of a thing where you just expect it to do that on its own. Or at least to tell you, you can't do that because it's breaking the parent-child relationship. I do like, though, that there seems to be no rules in Onshape that it won't tell you you're doing something wrong. Yeah, which is, so many CAD systems do that. They just say, no, we're not going to let you do that. We don't agree. Yeah, actually, thinking about it, I don't think I've seen one error box come up in this session, which is kind of nice. Okay. Well, the outside looks awful. Well, there's a question. Does the outside need to be a polygon? I don't think it does. Now, I'm going to... I don't like how it doesn't snap normal to the sketch. To me, that should just do that automatically. It should always, as soon as you create a sketch, it should just go normal. That looks much better. Let's change that to 14. I've written this little equation in here, but it won't let me edit it. I can only delete it or overwrite it. So I need to fix that on shape. Just make it 21. So the circuit board will just sit in there. Let's put these holes in. From the edge of that hole to the edge of that hole is 90 millimeters, 26 millimeters wide. Half of 90 is 45. Now we'll do an extrude, remove through all, breaking through. That's weird. Why? How can that be breaking through? It doesn't break through on these components. Maybe I've screwed up a dimension somewhere. Oh, it's clear I've made a mistake here somewhere. 1, 2, 3, 4, 5, 6, 7, 8. I can't count. 1, 2, 3, 4, 5, 6, 7, 8 segments. And I've got this as 12. So 360 divided by 8. 45. Will it rebuild or have I wrecked everything? Yeah. Cool. That's better. Now let's edit this circular pattern. Okay, that's not looking too bad now. Now the question left is, what do I do? What do I do to support this in the middle? Keep that in place. For that ledge that it sits on, will that be enough? Just to wedge it in there, because it's going to be a tight fit. Yeah, let's just leave it like that. Okay, I'm happy with this now. SOLIDWORKS, that really sticks out when something's wrong, and it will just annoy you so much that you've got to track everything down and fix it. But it seems like in Onshape, it doesn't care. It doesn't care what you do and how you make mistakes. So I think it's going to be really forgiving for people who are new to CAD. But the downside maybe is that when something goes wrong, you're going to bloody struggle to find out where it is, because it's not going to be leading you to it. You're going to have to really go hunting to find out what you've screwed up. And if you're like me, you tend to make 100 little mistakes every day and have to go back and repair them along the way, like not being able to count up to 8. In Onshape, there's no save button. It's all in the cloud and it captures everything you do. Now what I want to do is save this as an STL file so I can print it. Let's try export. Onshape enables you to export parts. Okay, there's not a lot of options available with this. It seems pretty dumbed down. I'm used to being able to adjust things quite a lot. Options download. Let's just go OK. Ooh, it's done. That's not very big. 457K. I'm going to email that and we'll see if we can get it printed. So here's the part being printed now. The light white material is a support structure. We'll break most of that away and dissolve it off. It looks like it is about nearly a third of the way through, which is really good. The initial print time was shown as 5 hours, 5.5 hours. But over here, if I press on show time, time remaining 3 hours. Here's the finished component. Just off the printer, just took it off just now and just cleaned it up. All the support material came off quite easily because it was still a bit warm. The circuit board doesn't quite fit in. It's just a smidge tight. That's okay. We can just clean that up with a file or with a die grinder or something, or even put it on the lathe and machine that out. And but yeah, looks really good. It's going to be quite strong. And we'll just disassemble this, replace it with the white component, and it'll be great. So I'm going to leave that for Bernard to finish off. Okay.